All right, guys. Well, this is our first lesson for Honors Geometry A. We're going to talk about points, lines, and planes. These are like the most basic parts of geometry that you have to know in order to do everything else we're going to talk about. Okay. Now, technically speaking, points, lines, and planes are kind of like undefined terms. We just kind of think we're thankful that they're there, and we just use them. But we're going to kind of define them just a little bit, and we're going to talk about how to use all that stuff. All right. So we're going to start with a point. So we can think of a point simply as a location, okay, and it has no size. And when we write a point, we always use capital letters, okay? Now I should point out real quick that I'm making this video with a document camera, and the way I'm having to write, my hand covers up what I'm writing. So if you need to, you can pause it after I write something so you can copy it down. Um, just want to throw that out there so you know what to do. Okay, so a point it's a location, no size, and we always use capital letters. Okay, so here's an example I've given you. We would say this is point A. Boom, there you go. Super simple. Okay. Then we talk about a line. We can think of a line as a series of points extending forever in two directions. Okay. So kind of think about it on this line example I have over here. This line has infinitely many points on it. I've just picked out two of them. Okay, and I've labeled them for you. Okay, a line has no thickness or width. Okay, and this is important. There's a postulate, which a postulate just means we kind of take it for what it says. We don't necessarily have to prove it. Okay, but the postulate says that any any 2 points form a line. And you kind of use that in Algebra 1. When you were given 2 points, random points, and it said write the equation of the line between the 2 points, you were using this postulate without realizing it. Any 2 points I give you, you can draw a line through them. Okay? Now let's talk about naming a line. So here's the line example I've given you. Notice that I've labeled 2 points for you, and there's also this lowercase script in a letter at the end. So let's talk about how to name it. You can use those 2 points that I've labeled out, X, Y, and then on top you would draw like a miniature line. That's the best way I know how to describe it. Okay, a serious part about geometry is that it is so important that you label things appropriately, because if you mislabel something, it throws the reader off and they don't know what they're talking about. So when I write this way, we read this as line XY. Okay, when you draw the miniature line on top, that tells me, hey, you're talking about a line. Okay. You can also label this line YX. Okay, you can go from X to Y, or you can go from Y to X. It doesn't matter. Now let's talk about using that little script. So if you're going to use a little script, you actually have to write out the word line and then put the little script. Okay. These are the two most common ways to name a line. This one, to me, is less preferable. But this is the way I normally write lines, with 2 points and then with the line on top. Okay. Let's talk about collinear points, and that's a fancy word, collinear, but it basically just means points that lie on the same line. That kind of makes sense because the word co means together, and we're talking about linear, so they have to be together on the same line. Okay, so let's draw us a little example here. There's my line. It's beautiful. So we've got A and B. So we would say A and B are collinear. Why? Because they're on the same line. Okay. And on the flip side, non-collinear points are points that do not lie on the same line. Okay? And there's a specific condition here. We have to have at least 3 points. Okay? So let's see why. Let's come over here and draw us another example. So let's say A, B. Let's throw another one on here at the end. So at this point, I could say A, B, and C are collinear because they're all on the same line. But if I throw a point D out here, then I would say A, B, C, D are non-collinear. Or I could just say A, B, D are non-collinear, either way. If one point does not fall on the line, it throws the whole thing off. You can't say they're collinear. Okay? And then let's talk about intersecting lines. So also in Algebra 1, when you talked about systems, this is what you were doing. You would graph 2 lines and see where they meet. And that's another postulate. So if we're talking about intersecting lines, we say that two lines intersect at a point. Okay, that's important. So 2 lines are going to intersect, they intersect at 1 point and 1 point only. So over here on this example, we could say lines R and S intersect at P, right? Because they cross here at P. All right, let's talk about a plane for a minute. So now we're leaving, like, lines are kind of like one-dimensional if you want to think about it. We're going to like a two-dimensional kind of thing. So a plane is a flat surface and it extends indefinitely in all directions. Okay, I think this is the easiest way I think about this is that you could kind of think of a plane as the floor of a room. So like it kind of has boundaries here, but in reality, we know it extends forever this way, forever this way, forever that way, and forever that way. It goes on forever. Okay. And then we say any 3 non-collinear points make up a plane. And we say that because we can't have all 3 on the same line because then we wouldn't necessarily have the plane. Like if I was able to draw a line between all 3 of these points, we necessarily wouldn't be in a plane, it's just a line. So the 3 points have to be non-collinear for this to work, okay? As far as naming a plane, we can talk about naming the plane. We can name it by those 3 non-collinear points. So we could say plane KJL, or you could switch the letters up if you wanted to. JKL. I mean, you get the idea. You could do any arrangement of your letters. That's fine. Now, there's something else in here. This down here in the corner. Remember on the line we had a lowercase script letter. On planes, it's uppercase. That's your second way to name a plane. Okay, so we could also call this plane P. Okay, and the script letters will always be in the corner. On a plane, they're capitalized. Okay. Let's talk about a couple more things. And we're going to talk about coplanar points. It's a similar idea to collinear points, but from a plane perspective. So these are points that lie on the same plane. Okay, so if I draw me a plane, just put me some points in here. Q, R, S, I can put another one in here. So we could say Q, R, S, T are coplanar because they're all on the same plane. Okay, and then on the flip side, non-coplanar are points that do not on the same plane. And here we have to have at least 4. We need at least 4 points to say they're non-coplanar. All right, so I'm going to draw, this drawing looks a little bit more difficult, but so I'm going to draw a plane going this way. I'm going to draw another one intersecting it. Something like that. Not the best artist in the world, so dash, 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 dash. Okay. So we're gonna put Q right here. We're gonna put R right there. We're gonna put S over here and T right here. Okay. Now I'm gonna draw this in also because I'm going to talk about it. But just so you know where the boundary line is at. So in this instance, it looks like Q, R, and T are all on the sideways plane, and then S is in this up and down plane. So we would say here that Q, R, S, and T are non-coplanar. Okay. And then finally we have intersecting planes. This is the last postulate. So we would say that 2 planes intersect at a line. And so on this example here, I would say that planes L and M intersect at line K. Right? Because you got plane L is vertical, plane M is horizontal-ish, and then they're meeting here at this line K. Right? So that is all the notes and theorems and postulates and stuff we're going to use. So let's look at some examples. All right, and I'm going to try and do this kind of quickly because I don't want this video to be too long. I'm already at 15 minutes, but anyway. Let me let this up here. All right, so we're going to use the figure over here to answer the following. So 4 collinear points. So I need 4 points that are all on the same line. Well, I got 3 here, got 3 here. Does this one have 4? Yep. So we would just list them out. H, N, K, and I. Okay. A line that contains the point M. So let's find M. It's right here. Now you could say use M and another point on the line with it. So we could say line MN. We could even say NO, because if you put the lines, that is a terrible line symbol. If you put this on top, that's all the points that have N and O on them. So N and O, and you stick indefinitely, you're going to get to M eventually. So that is also a valid answer. You could also use this lowercase script here at the end. So if it's at the end, it goes with that line. So M is on this line, so we would say with P. So line P is also an option. A line that contains points H and K, well, H and K are on the same line, so you could actually say HK like that with your line symbol on top. Or you could use a lowercase script, which in this case would be line R. Okay. Another name for line Q. Line Q is right here, so you could use any 2 points on this line to name it. So my first thought, hey, we could use JL, or we could even use KL, or you go backwards, LK, JL, or LJ, it really doesn't matter. Okay, the intersection of lines P and R. Remember, 2 lines intersect at one single point, so let's find where that's at. P and R looks like they intersect at point N. Okay. Next, we're going to use this new figure, a line containing the point F. So where is F? It is right here. And so you could use any of those points on that line. So my first thought, we could say, we could use DE. You could use EF. Or you could use the lower script again. So this would be line J. Another name for line K. So where's K? It's right here. It is actually going through this horizontal plane. It's not inside the plane. It just meets it at one single point. So if we're going to name line K, we could use any point on that line. So we could say CE or BC or those other options. I'm just listing out a couple. Okay, a plane containing point A. So if we're going to name a point, we've got to have 3 non-collinear points. So 3 non-collinear, A, D, E. That's the first one I see. That pops in my head. Okay, you wouldn't want to use C because C is on this line K. It's not even contained inside that plane. So we don't even include C on your answer here. Okay, it's got to be inside here with the A. Or we can name a plane using our capital script right here. We could say plane M. Okay. Next one is an example of 3 non-collinear points. So we want 3 points that are not on the same line. So my first thought was to use A, D, and E again. That would work. Now you're thinking, but Mr. T, D and E are on the same line. That's true. But if one of these points you list out falls off that line, the whole three, the set of all three is non-collinear. It applies to all three. Okay? There's other examples you could do there. I'm just picking out one. The intersection of plane M and line K. So where do they meet at? It looks to me like it's at point E. That's a little weird to see. So the line comes through the plane and it's crossing right here at E. Okay. Now, it looks like now for the third one, it looks like I've got a box there, but it's actually a bunch of planes intersecting each other. And these boundaries here are really lines. Okay. So just keep that in mind. We've got planes intersecting here and we've got a bunch of lines. Speaking of lines, there's no way for me to put this on here. So these are actually supposed to be lines right here. So let me draw those in. And I want you to draw them in on your paper so you know what we're talking about. So where do the lines DH and AD intersect? So let's look. DH is right here. And AD is right here. Looks to me like they intersect at point D. And I can tell that because they share that point in their line names. Okay. The intersection of planes ADC and DHG. So let's look at that. I follow those letters. ADC. That's kind of like the top of the box here. And then DHG, that's the side. Planes have to intersect at a line, so do those planes meet at a single line? Looks like they do. It looks like they're meeting right here. So we could say DC. With your line symbol on top. All right, now let me clean this up a little bit because the next one's this a different problem. All right, the intersection of planes CDFE. So let's look at that. CDFE. Well, that's weird. So there's a phenomenon sometimes that happens where I could ask you about a plane that would cut through the inside of this box. It could be like the diagonal of the box, if you will. So let's draw that in. So we're talking about that plane that cuts through this diagonal of the box here. Okay? So CDFE is right here. And HGF. So HG. I think I covered it up. Where is it? HGF. Oh, HGF's the bottom. My bad. That's my bad. I'm sorry. Okay? So ask yourself, does the bottom of the box and that diagonal plane, do they touch anywhere? And they do. They touch at this line over here. So I would say that is EF. That is horrible. I can't even read that writing. EF. Or FE if you want to. All right? Let me clean this up. Sometimes you do this. You mark up your picture and then you got to erase it so you can mark it up again. All right, last thing. The intersection of planes ABE and CDG. So let's see that. ABE, that is the far side over here. CDG, that is this other side. Do those planes intersect? Looks like they don't, so we would say no intersection. We'll actually learn tomorrow But that's an example of parallel planes, but we'll get into that tomorrow. It's just a little taste of what we're seeing, something you'll see tomorrow. Okay, I think that's all that I have. Yep, so there's your points, lines, and planes assignment. So this video will be posted for you to watch. I would suggest either taking these notes along with me, or if you're able to print out a copy of this and do it along with me in the video, that's perfectly fine, whichever one works for you. But there will be a homework assignment attached on Google Classroom with this video, and on there I will tell you what specific problems you have to do. Okay?